All right, so all this week we'll be doing as much of a review as you want. Follow along as little or as much as you want. Today we'll be doing an exercise that we talked about briefly last week, and then I didn't have anything else planned, so Wednesday and Friday probably exercises from Advent of Code or something. So this was already posted last week in the retrospective. The final exam for this course is scheduled for Monday, December 12th. The exam will consist of two parts, 24 multiple choice questions, plus 9 ungraded survey questions at the end. The entire thing should take no more than 45 minutes for that part. It's language agnostic. It doesn't involve C at all. It's just computational thinking and pseudocode. That is worth 66 points. So about 6% of your grade, or 66 of the 150 for your final. And then the remaining 84 points is from your from a programming exercise. It's cumulative in the sense that you can't do searching and sorting if you don't understand, the basic loops. You can't do searching and sorting, or if you don't understand. You can't do structures if you don't understand strings, right? But the emphasis, of course, will be on structures, searching, and sorting, and more recent stuff. There's 9 points for the usual style, documentation, and design, and then 75 points for correctness. You're going to be submitting that through the web hand-in, grade it through the web grader. You can resubmit as many times as you want during that period, and regrade it as many times as you want. There are several parts to the exercise. You'll be producing several reports, and so partial credit is possible on the correctness because it's 75 points. It's half of it, but it is absolutely essential that you submit code that compiles and runs. If it doesn't compile, if it doesn't run, it's an automatic 0, right? So if you've got, say that there are 4 reports that you can do. The first one works, the second one works, the third one doesn't work, and then the fourth one works. Take the code out so that at least 1, 2, and 4 are working, right? Yeah, you'll lose the points on that one report, but at least you won't lose the points on all of it, right? Both parts, the A and B, the multiple choice and the programming part, open at 12:01 a.m. in Canvas, and they both hand-ins close at 11:59 p.m. that day. I forget when the official time is, but cumulatively together, the first one should take no more than 45 minutes. The second one should take no more than an hour. So it is designed for that 2-hour time period, but you'll have that entire 24-hour period if you want, especially those online. You're not restricted to any particular time. There are no makeups, so plan ahead. No collaboration of any kind is allowed. Do not even bother going to those the cheating websites that we know about. We'll shut that down as quickly as we can, right? So no collaboration with other students. We'll be running MOS, measure of software similarity, like we've been running before. We will be monitoring hand-in logs, so make sure that all the work is your own work. Now, if there is a piece of code that you wrote together with Joe in Hack 10, yes, you can use that. That's not cheating. We're not expecting that to be. Even if that pops up in MOS and there's a good explanation for it, we're not going to even bother looking at that. If MOS is pretty good about getting rid of that kind of, or seeing through that kind of stuff. Any questions on the final exam? Otherwise, that's a week from today. Okay. All right. So remember, I told you about this exercise here where we've got a database of official Pokemon, 800 official Pokemon here. Each one has a name, a type, a secondary type or type 2. Some of them don't have it, in which case I put this this placeholder here, none. Right? They've got a number of hit points, which is if you've never played games like this before, a hit point is your energy, and so when you're attacked, all right, your hit points go down, and when you hit, you lose or you die when your hit points reach 0. I think that this is the attack and this is the defense. These are just numbers, right? Whatever they actually mean. Again, I've never played the game. If you've played the game, great. It's not necessary to understand the game to understand what we're going to do with this report. Right? Otherwise, over here, we've got 805 Pokemon. So we've got 5 Pokemon that were created by fans. And their stats were made up, and they're not an official part of any game. What I want to do is I want to find those 5 Pokemon. Okay? That means that we're going to be searching and sorting. That means we probably want to model this problem starting with some sort of a structure. Right? I do have some starter code here, so we're not starting from absolute scratch. The starter code that I have here is loading up that CSV data from a file. Now, again, the file I/O is not going to be the focus, but it will be necessary to understand file I/O to do the final exam. So I do want to walk, but I didn't want to start from scratch here. So I'm going to walk through this function line by line. Right? First of all, it returns an array of Pokemon. Right? That's going to be, we're going to have to define what that is. That's a user-defined structure. Okay? It takes a file name and it takes a num records integer by reference. Why does it take this other parameter right here? If I open up that file and I read in 100 Pokemon, or if I read in 800 Pokemon, or 805 Pokemon, I have to tell the calling function how many records I read. That's where num records comes in. Would I be able to tell the calling function how many records are in that resulting array over here if it were passed by value? No, right? Because that's going to be a copy of whatever num records from the calling function is being passed in, rather than a pointer. There's no way that I can communicate that back to the calling function. Line by line here. If either one of those things is null, I return null, because it returns a pointer. That's the only thing that you can return to indicate that an error occurred. Okay? Otherwise, I create a buffer. I open up the file for reading, right? That's what the R is for. If the file opening failed for any reason, right, the file didn't exist, I didn't have permissions to read from it, or something like that, right? Then it would fail and it would end up returning null, and I could return null back. Otherwise, after this is done, right, now I can start reading the file line by line. To read it line by line, I'm using the fgets function, fgets. File, get, S stands for string. Get an entire line of data, right? And an entire line of up to 1,000 characters here. This is just large enough to hold anything that's in either of these two files, okay? The first line tells me how many records there are, right? I'm cheating here by encoding that in the first line instead of like a regular header or something like that. And so I'm making it easier on myself, converting that over to an integer using A to I, communicating to the calling function how many records I'm about to read, and then I set up memory to hold that many records. How many bytes does a Pokemon take? Size of Pokemon. How many of them do you want? N of them, because that's what the first line of the file said. Right? Then I go through using a regular old for loop here, and I get the next line, and I break that line up. Right? It is a comma-separated value file, CSV file. Each one of these pieces of data is separated by a comma. Right? Come on, why are you not working? There we go. Comma, comma, comma. So I'm going to use strtokenizer, to tokenize each one of those pieces of data. The first time I call strtok, I pass in the string that I want to tokenize, the buffer that I just read that line from. I want to tokenize it on this delimiter, comma, because it's comma-separated values. Each subsequent time I call strtok, I pass in null to continue tokenizing that same string. Okay? The first token is a string representing the name. Then the second one is the type, second type. And then after that, I don't bother storing them off. Instead, I immediately convert them to integers: hit points, attack, and defense. And then I hand that all over to this function called init Pokemon. When you did your Lab 11, Hack 11, right, there were two types of functions that we created. There was a create function, create Pokemon, whatever. Pokemon, there we go. And init Pokemon, all right, airport, team, whatever else you did, right? Well, I think in class we were doing books. So we had a create book and an init book, right? One of them created one from scratch. In other words, it allocated memory. That's not what we're doing here. Instead, this is expecting it to already be allocated just because, like we did on line 25 here, right? It's already been allocated, so I'm just going to initialize all of its data, including the name, the type 1, type 2, hit points, attack, and defense. This is the first one that we're actually going to write. Before we do that, though, we have to define what a Pokemon is, right? So if this is a structure, what syntax do I use to define a structure? Type def, struct, right? And then I need to give it a name. Well, I've already given it a name, right? Pokemon, right, there we go. Inside those curly brackets, that's where I define what this structure is. Encapsulation, the grouping of pieces of data that act on that are logically define one thing, one Pokemon. Right? That's a name, a type, type 1, type 2, whatever, right? So, const char star. Some people did this on their airport, and then they could never ever actually, create an airport. Why? What does that const out front say? You'll never change it. If you can't change it, how do you set it in the first place? All right? So, nope. Char name. Char star name. That is a string. Do we use commas or do we use semicolons here? Char star type 1. Right? Which one? Semicolons. Why? It's not a list. Right? An enumerated type, you would use commas. Here, these are actual variables. When you declare a variable, what do you put at the end? A semicolon. Right? Char type 2. Right? What else was a Pokemon? A number of hit points. Right? Int, I think I said attack and defense. Right? You'll note here that I've taken out a lot of other data that's associated with this. One, to simplify the task, and two, to make it so that the task is not trivial. Right? Usually these are the original data that I got. Everything had a unique identifier, 1, 2, 3, 4, 5, so you could immediately find out what the 5 were, because I couldn't have 42 and another 42 or something like that. So I took those out. Right? And this is for our purposes, this is what a Pokemon is. Okay. Now I want to define that init function that we had. What should be my return type here? Let's come back to that. It was called init Pokemon, and it takes a pre-existing Pokemon, P, the name, const char star name, const char star type 1, etc. Right? Well, I'll finish typing this here in a second. But should it be taking it like this? Like just a regular old structure? Is that the C way of doing things? No. C, you want to pass in a reference to it. You want to pass in a pointer, right? So I'll pass in this pointer here. Now, we've got const and everything else. Why don't we put a const in front of that? Am I going to be able to make changes to that Pokemon and set its name, set its type, set everything else? Nope. So we don't want it to be const. Okay? Otherwise, type 1, const char star type 2. What else was there? It's right here. Int hit points, int attack, int defense. There we go. All right. And to do documentation. Again, it's only worth 2 or 3 points, but it's important to do it for your own understanding. Right? So what should the return type be here? Well, let's implement this and then we'll come back and fill in that blank. I'm going to go ahead and come over here to my source file, cut and paste the prototype or the signature there. Right? Now, generally, what's the first thing that I do when I implement a function? Error checking. What could go wrong here? The Pokemon could be null. Name, type 1, type 2, those could all be null. Hit points, I don't know much about Pokemon, but I don't think that you can have negative hit points, right? Because you're already dead, right? Or 0 hit points or something like that. I forget what the minimum and maximum we saw in this morning's section, but can you have an attack that's 0? No? Okay. You can't. a defenseless Pokemon. You could have that. Somebody said some fish one was 0 defense. Is that right? That's a lie. Okay, I'll trust you there. All right. So to do error handling. Right, that gets into the weeds of what Pokemon are and what the actual game rules are. I don't want to go there. All right. So if you were doing error handling, of course, your return value here would be an integer. I'm not going to do error handling. I'm just going to keep this as a void for now. To do error handling if called for. Right. ... Okay. Otherwise, I'm going to take and copy the name into the Pokemon's name, copy the type into the Pokemon's type, etc., etc. So I want to set P's name to name. How do I do that? P dot or P arrow name is equal to name. Right? Which one? Arrow. Why arrow? Because it is a pointer, exactly. Right? Now, is this the correct way of doing it? P's name is equal to that name. What kind of a copy is this? Remember, there are two kinds of copies. There was a deep copy and a shallow copy. What kind of copy is this? This is a shallow copy, right? Shallow copy is when you have two references, P's name and the original name, and it's pointing to the same string. Changes to one will necessarily change the other, right? We don't want that to happen. We want a deep copy. How do we do that? We need to first set up memory for it, right? So a call to malloc. How many bytes do you want? Size of char, you want a number of characters. How many characters do you want? strlen of name. Is that it? HELLO. Is 5 enough? Plus 1 for the null terminating character. Plus 1. There we go. Now, does that copy the name over into name? Nope. You also need to do strcpy, right? Into P's name, name. Copy paste for type 2. Copy paste for type 1, right? Or what should I have done to begin with? Write a function. Let's come back over here, and first of all, let's complete this. We said void, right? And let's go ahead and write a deep string copy. Char str deep copy. Right? Const char star s. Right? In fact, you've written this function maybe, or you've had an opportunity, or at least in class, we've written this function at least 3 times now. Right? You could go back to your old copies and just simply reuse that function. Okay? What does it look like, though? I shouldn't have erased it. I could have copy-pasted it, right? Char star copy is equal to a call to malloc. How many bytes do you want? Size of char times strlen of s plus 1 for the null terminating character, and then strcpy copy into s, or s into copy, and then return copy. Good. Make sure that you are bringing in the string library because that's where all that stuff lives. I already did. Right? And now I don't have to write those 2 lines over and over and over again. Instead, P's name is equal to str deep copy of name. Likewise for type 1, type 2. Type 1, type 1, type 2, type 2. Do I need to worry about deep, shallow copies or anything for just regular old integers? Nope. Right? Those are passed by value anyway. Right? P's hit points is equal to hit points. Right? P's type 1 is equal to type, not type 1. Attack, I already did type 1, is equal to attack. Right? And P's defense is equal to defense. There we go. It's a void function, so do I return anything? Nope. You can leave off the return keyword here, but it's best practice to leave it in there. To explicitly say, yes, I am returning nothing. I understand this is a void function. Okay? Okay. Great. So far, I have implemented this load CSV data. I'm loading it from the fan database, and I'm loading it from the official database. I am passing in N and M by reference so that I know how many are being read from the file. Let's actually, before we get into our reports, let's make sure that this actually works by printing out the contents of this file, right, after we've read them in from all the Pokemon from those files. Let's just do one from the fan, right? For int I equals 0, I is less than n, I plus plus, print out the ith fan Pokemon, dot, dot, dot. Right? Okay. So, if you're going to be doing this over and over and over again, maybe you want to write a function, right? So let's come over here and let's write another function, right, involving Pokemon. Void print Pokemon. There we go. Pokemon P. Now, is that the C way of doing things? Here's a Pokemon. Go ahead and print it out. That's passing it by value, right? Now, a Pokemon is only, you know, what is it? It's 3 pointers, which is probably 8 bytes each, so we're up to 24, plus another 3 times 4, 12 bytes. So what did I say? That's 36 bytes total, right? About. That's not that big of a deal. But you can have structures that are hundreds, thousands, millions of bytes. Passing them by value is not a great practice, because that gets copied. Passing it by value means that the entire structure gets copied onto the program stack. The program stack is small and defenseless. Remember, it is only about 8 megabytes, right, or whatever limit we saw, right, when we did functions and recursion, right? We don't want to abuse it. So generally, you want to pass in a pointer to your structure. Now, are you going to be making changes to it? No, I'm just going to be printing it out. So I make that promise. I am not going to be making changes to it. You might generalize this to, with a toString method that you then use within this method. I'm not going to do that. Right? Yagni. Do you remember what Yagni stands for? Right. You ain't gonna. We've talked about that, right? Need it? Right. Don't over-engineer things, right? If you're told that you have to do something, then do it. Otherwise, Yagni, you ain't gonna need it, right? Don't do it. Don't do it until you need to do it, right? Be lazy. Right there. Print Pokemon, right? Printf. I won't get fancy here. Here's the name, right? Within parentheses, I'll go ahead and print the first type and then the second type with a slash there. Then those 3 numbers, %D, 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 right? And then I'll end the line, right? There we go. So P's name. P's, why am I using arrows again? Because it is a pointer to it, right? Type 2. That's why they use the arrow, right? It's reminiscent of it's pointing to that thing over there, right? And that's how you can remember the difference, right? Here's a pointer to a structure. You use the thing that points to a member variable in the structure, right? Type 1, type 2, P's hit points, right? P's, attack, and P's defense. Right? There we go. All right. Come back over here to the main where I want to use that function. Print Pokemon. Can I do this? Fan sub I. There's the ith fan Pokemon. Right? Well, remember, what is fan? Right? Fan Pokemons, if you want to. Pokemon. What's the pluralization of that? I have no idea. That's why I just called it fan and official. Right? Fan is a Pokemon star, a pointer to a structure, right? Fan sub I is a regular old Pokemon structure, right? Fan is a Pokemon star. Fan sub I is a Pokemon. Does that jive with what we just did with print Pokemon? Nope, it expects a what? A pointer. How do we take a regular old Pokemon and turn it into a structure, or turn it into a pointer to a structure? Ampersand. There we go. All right. Get rid of this. just scratch work. Okay. Lecture, review, this section. There we go. I'm going to go ahead and bring everything together, GCC, Pokemon.c, and Pokemon data, or reports.c, and we're all good. So now when I run this, we should see the contents in order, Wormadam Sandy Cloak, whatever that is, and then the last one is Diggersby. All right, let's see if it works. Last one is indeed Diggersby, normal ground 85, 56, 77, and the first one is, after I scroll up all the way up here, there we go, there it is, bug ground 60, 79, 105. Looks like it's good to me. All right. Excellent. Ad hoc testing. I've tested it. Get rid of that code now. Okay. Now here's our first report. Before we get into finding those fake fan Pokemon, let's find the Pokemon with the highest hit points and the one with the lowest hit points. All right. Just to get into what we're going to do with searching and sorting. So what would be your easiest solution here? Right? This is kind of like finding the highest rated book, the lowest rated book. You could roll your own function. Right? Here's the array of books. Go through and find the minimum one with respect to the rating. Go through and find the maximum one. Or you could get it all done in one shot. How? Q-sort. Sort it by hit points. You want to do ascending or descending? In ascending order, right? So if it's in ascending order, right? Highest down here, lowest up here. So where's the lowest? Right at index 0, right? Where's the highest? At the last index, okay? So the lowest will be at index 0. The highest will be at index n minus 1. Why n minus 1? If we're searching the fan database here, right? There are n of them in there. Because of 0 indexing, the last one is always at n minus 1. Okay. All right. So, do I roll my own sorting algorithm? Do I cut and paste that selection sort algorithm from lab 13? No. As we already saw, it could take months, right, to sort reasonably sized arrays. Now that's not that big of a deal here. 800, right? 800 squared. That's no more than a couple of 10,000s or whatever, right? But I will guarantee you that what we give you on the final will have millions, tens of millions of data points, right? It will not be doable within the 5 minutes that the grader runs, much less several months if you're going to use some inefficient sorting algorithm, right? So let's do it right and do quick sort, Q-sort. Right? What were my arguments to Q-sort? First argument of, you're sorting something, right? So the first argument is the thing you want to sort. We want to sort the fan database of that array, that fan array. What's the second argument? So when you pass an array to a function, you always have to pass what else? The size of the array. N things are in that array. What's the third thing? Remember, Q-sort is agnostic of what's in that array. Am I sorting integers? Am I sorting doubles? Am I sorting Pokemon? Right? It doesn't know. You have to tell it. You're not going to be sorting, I'm not going to tell you what you're sorting. That's the comparator's job. But I am going to tell you that when you swap these two things because they're out of order, you're swapping 4 bytes or 4 bytes, or you're swapping 8 bytes and 8 bytes, or you're swapping 36 bytes and 36 bytes. So the third thing is the number of bytes each one takes. Right? What's that last thing? The comparator, how you're going to order things. How am I going to order things with respect to Pokemon for this exercise? By rating. So you need a comparator for Pokemon by rating. Ascending order. Right? Have I written that yet? Nope. So let's go back and write it. Right? What does a comparator look like? First of all, what's its return value? It returns an integer. Something negative, positive, or 0, depending on the relative ordering of these two things. Right? So if it's for Pokemon, right? Do we pass in Pokemon A and Pokemon B? Is that a comparator? No. It is only a comparator if it is generic. A generic is a void pointer, right? Just like malloc. And it has to be const because you're making the promise that you're not going to be changing it. You're just going to look at that thing and say, oh, it goes like this, this, or this. Right? So consequently, const void stars. Okay? That's a comparator. Anything else, and it is not a comparator. It ain't a comparator at all. Right? All right. Help me out. What's the very first thing you do in a comparator? Do we have enough information about A and B in order to look at its rating? Nope. We need to force A and B to become Pokemon, right? So const Pokemon X. I can't reuse A and B, right? And I will typecast it. Const Pokemon star. Yep, okay. A, and then the same thing for B, but I'll call it Y. There we go. Okay. So now here's something that you might see out in the wild, right? These are relatively small numbers. What if X's, so I want to compare X's hit points to Y's hit points. Let's do a thought experiment here first. I don't know if any of them are this low, but what if X's is 5 and Y's is 10 versus 10? Right? Are they in order if I'm going in ascending order? 5, 10? Yes. Right? So I would return something, want to return something negative. Right? What if it was 10 versus 5? Are those in order if it's in ascending order? Nope. So we want to return something positive. What if it was 10 versus 10? They're the same. Return 0. Okay? This is not code yet. This is just me thought experimenting here. What if instead I did the following? 5 minus 10. Oops, minus 10. What's that going to be equal to? Negative 5. That looks like something negative to me. What about 10 minus 5? That's equal to positive 5. That looks like something positive to me. What about 10 minus 10? That's equal to? That looks like something 0 to me. Right? Is that a good idea? Right? That's a nice trick. Right? Tricks will trick you up. Right? It's not that big of a deal for this use case because, I don't know, the Pokemon experts. What is the highest valued hit point Pokemon? Does anybody know? All right, you have to look that up. Or well, at least what's the value? Right? What's the maximum hit points that Pokemon can have? It's very game centric. Right? So anybody ever play the original Legend of Zelda? All right, you could collect rubies. What's the maximum number of rubies that you could collect? Nope, not 99. That's close. 255. 255? Why? That's always the maximum value of 1 byte represented as a number, as an unsigned integer. 0 up to 255. 256 possible numbers. You'll see that all over the place. Why? Because that's how computers work, right? And so they just set an arbitrary, they set, okay, you can't have more than that. Why? Well, then we need 2 bytes, and we don't have 2 bytes to spare, right? We just have 1 byte to spare. And so 255. It's not that big of a deal. But now think that you are think about actually doing this with real numbers. Right? Say 2.1 billion and versus negative 2.1 billion. Right? Now what is your trick doing? 2.1 billion minus a negative 2.1 billion. What is that equal to? 4.2 billion. Can you represent 4.2 billion with an integer? No, right? So, tricks are for kids. Don't do it. All right? Yeah. Good. That's what we found in this morning section. Good. Did you know that off the top of your head, or were you Googling? Okay, Googling it. All right. There we go. All right, how do I compare X's hit points? Well, if X's hit points are less than Y's hit points, then they're in order, and I return something negative. Don't get fancy, -1. Right? Else, if, same condition here, except that you reverse the order. If X's hit points are greater than Y's hit points, then I'll return something positive. Again, don't get fancy. It's just 1. Right? Else, what's the only other possibility? They're equal and return 0. That should always be your third go-to. Right? That shouldn't be the first one. Equality testing works for integers. Don't get into that habit, because then you'll forget about it when you're doing floating point numbers. Okay? All right. Excellent. Come back over here. How do I know if it worked? I could print them out again. Right? For int, now I wish I hadn't gotten rid of that ad hoc testing. And you see why we don't do ad hoc testing like that on a regular basis, because you don't want to be putting in debug statements, removing them, and now I need to go back and put it back in because I know I've got another bug, I've got another testing. Right? In real life, you do formalized testing using unit testing frameworks so that you don't have to rewrite and remove, rewrite, remove, remove. You put it all into a testing file like CMaka, and you just hit a button and rerun it every single time. Right? For int I equals 0, I is less than ni plus plus, print Pokemon of percent fan. We sorted the fan one, so by. There we go. I just want to see, has it been sorted successfully? Right? Let's expand this out here. Oh, oh, wow. Blissey is the one with the highest hit points. Did you know that too? Oh, okay, all right. All right. 255 Chansey, okay. And then who? Before I scroll up, then who wants to show off their Pokemon knowledge, or just keep it to themselves because they don't want to know? They don't want everybody to know that they know everything about Pokemon. What's the lowest HP? I don't know. Keep going. Here we go. There are 800 of them. Shedinja. And it only has 1. Aw. But there are no Pokemon that are completely defenseless, right? Or that are already dead, 0 or something. Right? So I'm convinced that works. Right? Again, go ahead and get rid of your ad hoc testing there. When you hand that in, don't comment it out. Don't leave it commented out. That's cruft. Okay. Likewise, this to-do is cruft. I'm leaving these in here though for demonstration purposes. Right? All of this stuff should just be removed. All right. Well, now that we've got our order, where is the lowest HP? Where is the highest HP? Printf. Highest HP Pokemon is at the very end, right? In an ascending order. It's that, what is it called? Blasty or Blissey? Well, we'll find out here in a second when we print it out. Print Pokemon ampersand fan. So it's at the end, so n minus 1. Right? And the lowest HP Pokemon is going to be at the very beginning. There we go. And now we're not going to get all of them. We're just going to get the 2 that we're interested in. Highest is Blissey and Shedinja. Right, there we go. Right. And again, there have been more Pokemon introduced since whenever I got this data. I just got it off of Kaggle. Is there anything higher or lower now? No? Okay. So we're still going with 1 byte, 1 byte representations, even though it's 2022. Right. Okay. The first Pokemon game was probably on a Game Boy, right? So they still, oh yes, if we're going to limit it, we're going to limit it to 1 byte because you still measured in bytes, even on like an embedded system like that, right? All right, now the main show here with the last 10 minutes. How do I find all fan-made Pokemon that are not official? I've got these 2 files here, right? One of them has 800, one of them has 805. What if I went through everything in the fan database and I tried to find it over here in the official database? If I found it in the official database, it's a good Pokemon. It's a real Pokemon, right? As real as they can be, right? So if I don't find it, if this guy is not over here in the official database, then we know that it is a fan-made one. Right? So let's outline that solution. Right? For each Pokemon in the fan database, search for it in the official database, Right? If found, it is real, right? And ignore it. Right? If not found, it is fan-made, report it. Right? All right? Sounds simple enough. Now, like I said, I took out the data that would uniquely identify Pokemon. They all have this unique numbers, 1, 2, 3, 4, all the way up to 800. So that's not how we're going to identify our Pokemon. Instead, a Pokemon in our database is identified by their name. Okay? So let's come over here and think about how to do this. Again, 800, not that big of a deal. String name, search for this one, matching string over here. I don't want to do it that way, because suppose now we fast forward 100 years and the 1000th Pokemon game has come out, and at this point now there are 10 million Pokemon available, right? Am I going to be able to do 10 million times 10 million operations in a matter of seconds? No. So let's think about a way to sort one or more of the databases and then efficiently search it. When we say efficiently search it, which one of those do we mean? Linear search or binary search? Let's go with binary search. All right? So binary search for it in the official database. To use binary search, though, what do we need to do first? Sort both arrays by name. Then binary search by name for it in the official database. Are we going to be able to reuse this comparator that we wrote? Nope. Why? Well, because it sorts by rating, right? If you did a binary search by rating for a particular Pokemon, add not rating. Why did I call it rating? Probably because I was thinking of the books. Rating. What should we have called it? It's hit points by HP. Okay. Are Pokemon rated? Like this is a better Pokemon. This is a worse Pokemon. It's all just balancing, right? That's what all RPGs are, right? All right. So I'm not going to be able to use that, but I will be able to use something if by name. Right? There we go. Come over here. Copy pasta. Right? Change to name. I will still do the typecasting, but do I do hit points? No. I'm comparing them by name. And a name is a string. Is there something that will help me do this with one line of code? String compare. Return strcmp x's name versus y's name. Now, is that sorting in ascending or descending order? Who cares? Right? I'm going to be using this to search by name. Right? As long as I use the same exact comparator to search, it doesn't matter if it's in ascending order or descending order. It just goes left or right the other way. Right? So let me go ahead and remove ascending. We'll just say by name whatever the default value happens to be. Right? So sort both arrays by name. How do I do that? Qsort, fan. There are n things in the fan database. Size of Pokemon. That doesn't change, but the comparator that I use changes. I want to sort the official one too. Official. Right? It's actually only necessary to sort one of these, but I'm going to go ahead and do both. Right? For each Pokemon in the fan database, for int I, in fact, I've got it up here. Let's steal it. There we go. I'm not going to print it out. Instead, what am I going to do? I'm going to binary search by name for the official database for that one. That means I need a key. Pokemon key. That'll be the ith Pokemon in the fan database. Does the left-hand side match the right-hand side in this case? It do. The left side is a regular old structure. The right side is a regular old structure. All right? I'm doing under the hood, I'm doing a mem copy of only 36 bytes, but that's no big deal. All right? Now, I need to use binary search. Binary search returns a pointer to the thing if it finds it. So Pokemon result is equal to a call to bsearch. Bsearch requires that you pass in the key, question mark, is that how we're going to do it? But what else? We're going to search the official database. It's exactly the same thing as QSort. You search the official array, which is of size M, and it contains Pokemon, which are a certain number of bytes, and you're going to use the same exact comparator that you used for quicksort. Right? Now, what about that key? Is that how I pass it in? Nope. Like everything else, it should be a pointer. That's a regular old structure. How do I change it into a pointer? Ampersand. Now, how do I tell if it's found or not? If it's null, then which one of these cases will it be? It was not found. Do I care about this one? No, I'm going to ignore it. So if result is null, then printf found fan Pokemon, right? And then I'll print it out. Print Pokemon percent key, or no, result. Oh, no, I just need to do result here now, right? Why? Because result is already a pointer. All right, let's see if this works. Now remember, there were 5 that I put in there that I just found on the internet. So we should expect those 5. You tell me whether or not they look official. Segmentation fault. Darn it. All right. Say again? That's official. All right, so where are you failing? Pokemon by name. Official should be M, right? There we go. Size of. Nothing untoward there. strcmp, xy. That looks good too. Right? There's the ith one. Official. M. Size of Pokemon. Darn it. Yeah, go ahead. Duh. Thank you. Right. So it is null, and so what I end up doing? Passing in null, and it seg faults because it can't print that. What I actually do want to print is key, because key is in the fan database, but it's not over here in the official database. So print out the key, but I can't do that because it's a regular old structure. It expects a pointer to a structure, so I need the ampersand there. Let me restore this really quick and ask, what are the tools that we could use to find out that it's seg faulted on line 41? Valgrind, right? So GCC with the G flag, Valgrind, a.out, right? And then it would at least tell me that it seg faulted on line 11, no, not line 11, but there. Okay, that's the memory leak. String copy. All right, lots of memory leaks. Darn it. Where do I? Anyway, it'd be somewhere in here. There it is, right there, 65. Right? Nope, it originated on line 41 here. All right, there we go. So key, let's fix it. GCC, a.out. And now with 1 minute to spare, we did this in about 50 minutes minus whatever time we took to do the final stuff at the beginning. There we go. Well, that's the lowest HP. 1, 2, 3, 4, 5, it looks like to me. Fangarm, Hexna, Mislemoth, Volpan, and I don't know, Palazegagon, or whatever. Right. Are those indeed official? They're all stupid. Well, I read that somebody made a fan or fixed one of the games that they didn't like as a fan game, and they introduced these new Pokemon for it. I don't know. Anyway, there's that exercise.